everybody, this is Mrs. Henry. We're going to go through lesson 1-4, rational versus irrational numbers. It's very important to make sure that you take care of all the notes, being very conscientious, writing everything down, because these definitions are new to you. Rational numbers are numbers that can be written as fractions or decimals. Rational numbers include terminating, and repeating decimals. They also include square roots of perfect squares. So let's think of some examples. First of all, one of the important things is if you can take a number and you can make a fraction out of it, then it is a rational number. For instance, I can take 7 and make that into a fraction. I can make any number into a fraction by putting a 1 underneath it. Okay. Regarding decimals, a terminating decimal is one that ends, such as 1.25. After the 5, it ends. There's nothing in the thousandth spot or anything further from there. So a terminating decimal is a rational number. If you have a repeating decimal like 0.44 with a line drawn over the top, that means that that decimal repeats and it'll be 0.44444 forever and ever. That is also a rational number. Perfect squares, and we learned about those the other day. Perfect squares would be something like the square root of 64, where a number times itself gives you that answer. So in the case of the square root of 64, that equals 8, and that is a rational number. Irrational numbers cannot be written in fraction form. Irrational numbers include non-terminating decimals, and non-repeating decimals. So there's no pattern that's being repeated. It also includes the square root of non-perfect squares. Okay, so non-perfect squares would be something like the square root of 20. There is no number times itself that is going to give you 20. In fact, you should be able to remember by lesson 1-3 that square root of 20 is going to be 4 point something. It's in between the square root of 16, which is 4, and the square root of 25, which is 5. In decimal form, that's going to be a non-terminating decimal. It's going to go on forever and ever, and it will never ever end. It's also non-repeating. We would have no block that repeats, no block of numbers that repeats. So let's put all this together. I want to make sure that you keep coming back to these notes up top. The value of -12, is it rational or irrational? Well, let's take a look up top. Can you write it as a fraction? Yes, you can. You can put a 1 underneath it. So I got -12 over 1. That makes it rational. And that is, the explanation would be, it can be written as a fraction. Pi, you might remember from your 7th grade math class, is a number that is approximately 3.14. But there's a lot of numbers after that. In fact, those numbers never end. They go on forever and ever. And there's also no repeating pattern. So pi is definitely an example of an irrational number. So I'm going to write it up there by the definition. And we're going to write irrational. And I'm going to abbreviate a little bit because in decimal form it is non-terminating and non-repeating. Has to meet both of that criteria for it to be irrational. The next one is 0.6. That is a decimal, and that decimal does terminate. Look right here. After the 6, there's no other numbers, so that is a terminating decimal. Terminating decimals are what kind of numbers? They are rational. Seven over 8. It's already a fraction. What do we know about rational numbers? They can be written as a fraction, so this one has to be rational. Okay. And I'm going to put the same explanation as the first one. It can be written as a fraction because it already is. Okay, the next one we have 0.1234566, and then we have it an ellipse at the end that says ... That means that that number is going to go on forever and it will never end. Do you see any numbers repeating or any kind of pattern repeating? No, you do not. So we have a non-ending or a non-terminating decimal and a non-repeating decimal. Both of that criteria means that this is an irrational number. So again, it's non-terminating, doesn't end. That's what these dots right here mean. And it does not repeat. .33. The bar on top of the 33 means that it is repeating. So I have a decimal that is repeating. Look up at the notes up top. What kind of number is a repeating decimal? Is it rational or is it irrational? It is rational. Moving on to the square root of 20. You should know your list of perfect squares up to 15 by now. Look at your list. Is the square root of 20 a perfect square? Is there a number times itself that will give you 20? No, it is a non-perfect square. And non-perfect squares are irrational. I have a negative decimal, but that decimal does end. It is a terminating decimal, and we know that terminating decimals are classified as rational numbers. The last one on this page, we have a square root with a negative sign on the outside. Well, we need to look at the square root. Is 121, the square root of 121, is it perfect? Yes, it is, because 11 times 11 gives you 121. So if I were to simplify that, that would give me a negative 11. Negative 11, I can make into a fraction. Okay, so this is a rational number. All right, so looking at the square root, I know that it is a perfect square, and that's going to be our answer. Again, use your definitions. Have them beside you when you're working on classifying these numbers. Okay. On the back side, flip it over, we have Joseph, and he wants to find the side length of a square that has an area of 150 square feet. Okay. Is this going to be rational or irrational? So if I want to find the side of a square, we know that a side is length times width, or side times side, which gives us 150 square feet. So I'm trying to determine, is the square root of 150 rational or not? Well, I know for it to be rational, it has to be a perfect square. Is 150, the square root of 150, perfect? No, it is not. The square root of 144 is, and the square root of 169 is, but not 150. So this is going to be irrational because it is not a perfect square. On number 2, which of the values from the following list of numbers is not a rational number? So we are looking for irrational numbers. Okay. Okay, so let's try to find all the irrational numbers. Is 8.224 irrational? Well, it is a terminating decimal. Terminating decimals are rational. Okay, the next number is 5/9. It is a fraction. The very definition of a rational number is a number that can be made into a fraction. So 5/9 is rational. Again, we're looking for irrational. Square root of 25. Okay, is the square root of 25 rational or irrational? Remember, for it to be rational, it has to be perfect. Is the square root of 25 perfect? Yes. So it is a rational number. Let's take a look at the repeating decimal of 0.321. Okay, look at your notes. Is a repeating decimal rational or irrational? It is rational, so that cannot be our answer either. That must mean the square root of 30 is our irrational number. Okay, remember, for it to be irrational, the square root has to be non-perfect. Is the square root of 30 not perfect? The square root of 30 is our only answer because it is not a perfect square. Number 3, Brad converted 5/11ths to a decimal. The result was a repeating decimal. Does that mean that the value is rational or irrational? Okay, so 5/11, repeating decimal. Look at your notes. Is it rational or is it irrational? I hope you said that it is rational. And it is rational because it's in fraction form. And it's a repeating decimal. Okay. Oh, I'm sorry. Let me let you have a chance to write all that down. Number 4, I love this question. It's probably my favorite on the whole homework because all of these numbers are exactly the same except for each one has a little bit of a difference. We have to determine whether they're rational or irrational. So for A, we have 3.4567. That is a terminating decimal because after the 7, there's nothing else. So terminating decimals are rational. It doesn't ask you to, but you can put an explanation over to the side just so you know. Again, I'm going to abbreviate. Terminating decimal. Okay. What's different about B is you have these little dots there. Okay. That means that that number will never end and it never repeats either. You don't see a repeating pattern of numbers. Okay, so it's a non-terminating, non-repeating decimal. That makes it irrational. I'm going to put up here non-terminating, non-repeating. Okay, the last one that we have here has a line on top of the 7. That makes it different from everything else. That means that the 7 is going to repeat forever. It will never end, but it does repeat. So we have a repeating decimal, and if you look at your definitions, a repeating decimal is a rational number. Okay, almost done, guys. 5 is another great question. Okay, we have to figure out if the given values or if the answers, so to speak, are rational or irrational. Well, I've got 6, and then I've got the square root of 30. Well, is the square root of 30 a perfect square? Can I simplify it? That answer would be no. Square root of 30, there are no two numbers that will give times itself that will give me 30. So I am taking 6 and I'm adding to it an irrational number. My answer is still going to be an irrational number. It is irrational because of the square root of 30. Okay. Now, 5b is a little bit different. Both the 6 and the 30 are underneath the square root sign, so that means I can add them together. And that's going to give me the square root of 36. So I'm going to ask you, is the square root of 36 a perfect square or a non-perfect square? If you said perfect, then you were right, because the square root of 36 equals 6. And is 6 a rational number? Can we make it into a fraction? Sure, you can put a 1 underneath it. This is a rational number. Okay. The last one, we still have 6 and 30, but we have the square root of 6 plus the square root of 30. All right? Both of these are irrational numbers because neither one of them are perfect squares. I cannot add them together like I did on B. Okay? So I have an irrational number plus another irrational number, and that's going to give me another irrational number. So I hope what you're seeing is that if you have an irrational number, doesn't matter if you add to it or you multiply, its value is always going to stay irrational. Okay. We want on number 6 to give an example of an irrational number that is greater than 10. Okay? So here's what I want you to think about. What rational number or what rational perfect square will give you an answer of 10? That would be the square root of 100, right? Okay, so I need a square root that's larger than 100 that will give me an answer that's more than 10. So if I have an answer like the square root of 103, I know that's not a perfect square, so that makes it irrational. And I know that it would be maybe 10.1 or close to it. So I know that the square root of 103 would be an example of an irrational number. I also know that pi is approximately 3.14. Pi is also an irrational number. 3.14 is less than 10. So how many times could I multiply it by to make it larger than 10? At least 4 times. Okay, so if I had 4 pi, that would be an irrational number that is greater than 10. Okay, I hope that this has helped, and I'll see you later.